So that is an average of one question every year. So let us look at this trend of the pure polynomial questions, and even within that, of the pure 25 quadratic questions that were asked in the last 7 years, seven were related to discriminant. Seven were related to special expressions, and within special expressions, we have three, more categories. So those we will discuss. Five questions were related to sum and product of roots. Three were related to common roots or given roots. So overall, eight questions were talking about roots. And finally, three questions were a bit abstract. They were based on graph and range. So first, before we talk about quadratic, let's talk about polynomials in general. Uh, the general expression for a polynomial, when we talk about a polynomial, we should talk about its degree first. So the highest power of x is the variable which is given as the input. The highest power of x is the degree of that polynomial. Based on that degree, that polynomial is named. If the degree is 2, it's a quadratic. If the degree is 3, it's a cubic, and so on. Now the general expression of a polynomial is f of x is equal to ax to the power n plus bx to the power n minus 1 plus cx to the power n minus 2, and so on. Now, right off the bat, you should know this result. What is the sum of the roots? What is the product of the roots? What is the sum of the roots taking two at a time, and so on? So, there was a simple method to do that, a simple method to remember that, and I will reiterate it here for you. You will first put signs. So this goes with plus, then minus, then plus, and then the signs will keep on repeating. So your first step is to arrange the given expression in decreasing order of power. That is your step number one. So if I were to write the steps, arrange. Second is you make sure if there is some term missing. If let's say x square is missing, you write it as 0x square. So, accommodate missing powers. This is your step number 2. Your step number 3 is sign distribution. So once you have arranged them in decreasing order of their powers, and you have accommodated for the missing powers by giving a zero coefficient to that, then you will start giving this sign starting with plus and starting with plus with the first one. Now from the left you will start sum of the roots is going to be minus b by a. A has a plus sign always, so minus b by a. Sum of the roots taking two roots at a time, which would look like alpha beta plus beta gamma plus alpha gamma, and so on. Basically, you selected two roots, you multiplied them. So you made all the selections possible of two roots out of the given roots, and then you multiplied them with each other, the two selected ones, and you added them. So for a cube, that is going to be three such terms. How so? 3c2. You selected two terms out of three, that is going to be 3c2. So s2 is going to be plus c divided by a. And you will keep on doing this until you reach at the last term, which would have been the constant term of the polynomial. And accordingly, you will arrange the sign. It could be plus, it could be minus. So for a quadratic, it is plus. For a cubic, it is minus. Right? So for even power, it is going to be plus. And for an odd power, it is going to be minus. The last coefficient, let's say that is your constant k divided by a. This is your product of roots. So far clear? If I give you any random polynomial, and some question on roots is based upon some question on roots is asked, you can do that. All right, great. This is one way of representing a polynomial. There is another way. Let's say alpha 1, alpha 2, alpha 3, and so on are the roots of this given polynomial. Excuse me. Yeah, let's say alpha 1, alpha 2, alpha 3 are the roots of this polynomial, then you can express this polynomial f of x as some constant k into x minus alpha 1 into x minus alpha 2 into x minus alpha 3 till x minus alpha n. Now, I have not talked about the distinction between alphas. Maybe alpha 1 is equal to alpha 2. Maybe alpha 2 and alpha 3 are imaginary numbers. That is also possible, in which case you would probably not write it as this and you will just write it as x square plus something. Because those are imaginary roots, you would not want to write it like that. So that is also possible. Doesn't matter. The use case for this I will show you towards the end of the class, but this is another expression that you can have for your polynomial. So you have a general expression which is predominantly used for some product of the roots, and you have a factor expression which is predominantly used for sign changes and remainder theorem. So we'll quickly come to those things. But for now, let's park it and move forward. What are the maximum number of roots that are possible? For a polynomial of n degree, maximum number of roots that you can have is n, which is the degree of the polynomial. The caveat is, when I say maximum number of roots, I'm talking in terms of the real world. So n real roots is the maximum that you can have for a polynomial. What were the roots? Roots were the values of x for which the polynomial was giving you an output of 0. If I put the root in this expression, f of, let's say the root is alpha, then f of alpha should give you 0, which is much more clear in this expression, right? Alpha 1 is a root. If I put alpha 1, this term will become 0, and then you will have 0 into whatever is going to give you 0. So you can have at max n real roots. So far, everyone's with me? Great. So maximum number of roots we have discussed, and the reason why you have this distinction, why can't we have exactly n roots, is because a function may not come back and intersect the x-axis again, in which case you will not get a root. So is there any distinction between odd and even polynomial? And by odd and even, I mean the degree of the polynomial. If that is odd or if that is even, what are the possibilities? An odd polynomial will have at least one real root. And the reason for that is simple, because your f of x, the highest power, whatever it is, because it is odd. If I put positive infinity in this, you will reach positive infinity. I am assuming a is positive. And if you put negative infinity as an input, this expression will go towards negative infinity, which means you have to connect a and b. And if you do that, there is no way possible without crossing this line, because they lie on the opposite side. Uh, they lie on the opposite side of the x-axis. All right. Secondly, imaginary roots exist in pair. So that is something we will quickly discuss now. Now let's make our way towards quadratic functions. You have this ax square plus bx plus c. This is the standard expression for a quadratic function. What are the sum of the roots? This will have two roots, alpha and beta. Because this is an even function, even as in the degree of that function is even, it can have zero roots, it can have, or two roots. Or if it has one root, it will be repeated. All of these cases we will discuss. Sum of the roots will be minus b by a. Product of the roots will be plus c by a. B and c themselves can be negative, it doesn't matter to me. I will write my expression for this like this: ax square plus bx plus c. All right. What are the actual roots? So why quadratic function is so important in our, in the context of CAT is that, it is the only polynomial where you can find the roots exactly. There is a proper formula for the roots. It is possible to manipulate a quadratic function and derive a formula for the roots. So your alpha and beta are going to be minus b plus minus under root of b square minus 4ac divided by 2a. This is something you have to memorize. I would hope that by now you have memorized this. If not, then this is your priority 1 to 10. This gets you so many places. This entire topic, arithmetic also, you may end up using this. Wherever there is a quadratic, which is a lot, you will be using this formula for the roots. So the values of the roots are either minus b plus under root b square minus 4ac by 2a, or minus b minus under root b square minus 4ac by 2a. Now the question of being imaginary comes into the picture because of this term that is sitting here. So we call b square minus 4ac as our discriminant. This is called as the capital D or small d, whatever you like to call it. If this is negative, would your roots be real? If you have a negative, if you take a square root of a negative number, will you get real values of x? No, right? Because square root of a negative number does not exist. What are the two things that you see in front of it? In fact, what is the key difference between alpha and beta? This minus b and 2a is common to both alpha and beta expression. This under root of d is also common to this expression. The only thing that is different is the plus and the minus sign, which means that if one of the roots is imaginary, then the other one will also have to be imaginary because it will also have the same term. So if alpha is minus b plus, under root of some negative number, then beta will have to be minus b minus under root negative of the same number, which means that the imaginary roots exist in pair, and that pair is conjugate pair. Their signs are changed. Apart from that, nothing else changes. The real term and the imaginary terms are same. It's just that in one of the roots the real gets added to the imaginary, and in the second one the imaginary gets subtracted from the real. So imaginary numbers always exist in pairs, which means that if a polynomial has a degree of 7, then what are the possible number of real roots it can have, assuming that none of the roots are repeated? You can have 1 root, 3 root, 5 root, or 7 root. Because if there is one imaginary, then the second one will also be imaginary, which means that imaginary numbers, imaginary roots occur in even numbers, either 0 or 2 or 4 or 6 and so on. So far everyone's clear on this. Now we will quickly discuss what these A, B, C, and D's mean for us. I have already established, hopefully, that capital D, the discriminant itself, is going to be the most important part of this entire, discussion. The second most important is going to be your A, the value of A, because the value of A decides what is going to be the orientation of your quadratic graph. So we all know the graph of a quadratic is a parabola. It can either be like this or like this. This is decided basis the sign of A. If A is positive, then you have an upward facing parabola. If A is negative, then you have a downward facing parabola. The B value decides the vertex or the sum. So this is your parabola. This midpoint or the lowest or the highest point is defined as the vertex of that parabola, the point of minima or the maxima. This is governed by B in partnership with A. This B also gives you the sum of the roots, which is minus B by A. As we all also know, a quadratic function is a symmetrical function. It is symmetrical around the vertex. If I have the sum of the roots, can I find the vertex? The vertex is going to be the average of the sum of the roots. So the vertex is going to be minus b by 2a. So this is your vertex and this is the sum of the roots. All right. The C value gives you what it always gives for any polynomial, which is the intercept value. What is the value of y when you put x is equal to 0? Where is this graph cutting the y-axis? This also gives you the product of the roots. This is plus c by a. So coming to the, topic at hand, the discriminant, which we would want to discuss a lot, is what does D determine? Your discriminant will determine if the roots are going to be imaginary, real or unequal, and real equal. If your discriminant is less than 0, which means that both the roots, based on this expression that we have seen here, both the roots are going to be imaginary. However, if this value turns out to be 0, if under root of b square minus 4ac turns out to be 0, would you say that both the roots will have the same value? Because your alpha will be minus b by 2a plus something which is 0. So your alpha will be minus b by 2a and your beta will be minus b by 2a minus this under root something which is also 0. So the value of the two roots is going to come out to be equal. So for you to have real unequal values of the roots, you need your discriminant to be greater than 0. So if your discriminant is equal to 0, you will have real roots. If you have your discriminant greater than 0, then you will have real unequal roots. So far everyone is clear on the coefficients and the discriminant. All right, great. So let us deep dive one level further, basis the signs of A, B, and C. Now, if A is greater than 0, B is greater than 0, and C is greater than 0, what will your parabola look like? First of all, because A is greater than 0, it will be curved upwards. Your intersection point with x-axis, your intersection point with y-axis is going to be on the positive side because C is greater than 0. What about this b greater than 0? What does this tell you? The vertex is going to be minus b by 2a. Now, if a is positive and b is positive, would minus b by 2a come out to be negative? Yes, it would, which means that your parabola is going to be something like this. The fact that will it intersect the graph, will it intersect the x-axis, will it not intersect, or will it touch, depends on D. It does not depend on A, B, or C alone. So this is going to be graph for the first one. What about the graph for the second one? Will it look something like this? Because between first and second, what has changed? A is same, so your parabola is going to be upwards. The sign of B is same as the sign of A, which means that the vertex is going to be negative. So it is going to be leaning more towards the negative x-axis. Only the intercept has changed. All right. What about this one? Your A is greater than 0, B is less than 0, and C is greater than 0. Now compare this to the first red graph that we had drawn. A is greater than 0, upward facing parabola. C is greater than 0, it is going to intersect the y-axis on the positive side. Only B has changed. Now B and A have the opposite sign, which means that this vertex is going to be positive because negative of a negative number is going to be positive. So your graph for that is going to look something like this. Graph for the fourth one. Now between third and fourth, what has changed? Only the C. Only C value has changed. So now it is going to be something like this. Correct? Now the remaining four cases are these exact same four cases just inverted because A is less than 0 for all of the remaining four cases. So the remaining four cases would look something like this. So this one, then you will take invert of this one and this one. So you get the idea about the graphs. Now, drawing the graph is one thing, but taking some implications out of that is, maybe much more important. So maybe for now, let us discuss A greater than 0 scenarios. So I will remove the negative graphs. Now, when you have A greater than 0, would you say that the graph has achieved a defined minimum value or a defined maximum value? Does the graph have a lower point, a lowest point, or does it have a highest point? Highest point is not defined, right? Because this graph will keep on going forever. towards infinity. So if you want to have minima, if you want to have a minimum value for a quadratic, a will by default have to be greater than 0. It doesn't matter what b and c are, they don't govern this. A will have to be greater than 0. If you want, and let me remove a few of the graphs here so that we have, more area here. Let's keep just this one. If you want to have maxima, you would need your a to be less than 0, because you want your parabola to be facing downward so that you have a defined top which is going to be your point of maxima. All right. Secondly, would you say that if your a is greater than 0, so I'm talking about the black graph here, if your a is greater than 0, when you know when you approach this vertex from the negative side, are you decreasing or increasing? Is the function value decreasing or increasing? Does this section of the graph, does it appear to you to fall down or rise up from going from left to right? It is falling down, right? So your function is decreasing right now. At this point, it has stabilized, and after this point it is going to increase. So an upward facing parabola first decreases until it reaches the vertex, in which point it achieves its minimum value, and then it rises up again. The vice versa is true for a downward parabola. So you first increase until you reach your point of maxima, and then you will decrease. So far everyone's with me? All right, great. Now let us discuss one last thing from this graphical perspective. If this is alpha and this is beta, this point, the point of minima, now I'm not going to call it vertex now, because I know that because a is greater than 0 it is going to be point of minima, so I'm going to call it by its proper name. If you have a point of minima, what is the exact point of minima? Alpha plus beta by 2, which is minus b by 2a. The additional fact here is that your quadratic is symmetrical around this. So if you have a point, let's say 10 units from this vertex, whatever the value the function will have at this point, it's going to be the same as if you move 10 distance, if you move a distance of 10 units in the other direction, in the negative direction, whatever value the function has, this height and this height, they are going to be same. This is what is meant by being symmetrical. The roots are also located at the same distance from this line of symmetry. Clear everyone? Can we move ahead? All right, great. Now let us discuss graphs with a and d. If a is greater than 0 and discriminant is greater than 0, what will your graph look like? Will it look something like this? It will look something like this. Your parabola will be facing upwards and your discriminant is greater than 0, which means you will intersect the x-axis 2 times. If the discriminant was equal to 0, let's say your discriminant was equal to 0, what would you have done? You would have just touched, which would have meant that you have only one root. The one root that you have is getting repeated. So in a factor format, will your parabola or will your quadratic look something like this? It was supposed to look like a times x minus alpha into x minus beta. Will it look like a times x minus alpha whole square? Because beta is equal to alpha, the roots are equal, so your function will look something like this, your quadratic will look something like this exact thing was asked in CAT. I will show you. All right, if your discriminant is less than 0, what will happen? You will have no roots. Now, is the position of this vertex along, is it because the parabolas I have drawn is towards the left side? Is it dependent on these two variables, a or d? Not independently, right? You need to know the b value. So for these three graphs, can you tell me what is going to be the b value? It is going to be the same as a, because your parabola The vertex is on the negative side. So minus b by 2a has to be negative, which means b by a has to be positive. And if a is positive, then b will also have to be positive, something we have already seen. So this is the case of imaginary roots. This is the case of real repeated roots. And this is the case of real unequal roots. Clear? All right, great. So the range thing we have already discussed for a greater than 0, because your parabola will look something like this, tending upwards, an upward facing parabola, your range will be some minimum value to infinity, something like this. If your parabola is downward facing, your range will be something like minus infinity to some maximum value. I will not put a rectangle around infinity. The minima maxima, again, you are clear on this. You only have to find the input, that minus b by 2a is the input for which the function will give me the minimum or the maximum value. And then you will write the function expression ax square plus bx plus c. This is the quadratic. If I put this here, I will get either my minima if a is greater than 0 or my maxima if a is less than 0. So the value minimum or maximum that the function can attain, it is obtained by putting this correct input in the function. So there can be two types of questions. At what point does the quadratic achieve its maxima? Are they asking you for the input or the output? At what point? They are asking you for the input. At what input will you achieve your maxima? What is the maximum value? What are they asking you for? The input or the output? They, in this case, they are asking you for the output, the actual value. And in this case, they are asking what is it that you will put as the input. So that will be minus b by 2a, and this output will be f of minus b by 2a. Clear so far? Yes. So then we will move ahead. So let us just quickly cover cubic functions. It is not something which is seen very often. Now, because it is an odd power function, the degree of this polynomial is an odd number, it is going to be having at least one root. The a value determines will you go towards positive infinity or negative infinity. So if your a is greater than 0, you will go something like this, from minus infinity to positive infinity. If your a value is negative, you will go like this, from minus infinity, sorry, from infinity to minus infinity. Again, something that is not used a lot. What we are more interested in is what are the different possibilities of roots for a cubic function. So, number one is straightforward. You have real roots. All three are real and all three are distinct. Now, if I take this section and push it a bit upwards, will I get something like this? How many roots do you have here? You have one distinct root and two repeated roots. So, in actual terms, how many roots do you get? 1 and 2. If you shift it further up, what will you get? Will you get something like this? Only one root. Only one real root. Can I decrease the number of roots further? No, I can't. You can also have one hypothetical situation where, not hypothetical, one special situation where the one root that was getting repeated is getting repeated three times. And if alpha, one of the roots, is equal to beta is equal to gamma, what will your function look like? Will it look like f of x is equal to a times x minus alpha whole cube? It would be a perfect cube function. If you have two real roots, and one is getting repeated, will your function look something like f of x is equal to a times x minus alpha into x minus beta whole square? Because beta is equal to gamma, this would have been the standard, format, a times x minus alpha into x minus beta into x minus gamma. Now, because x minus beta is equal to x minus gamma, I'll make it square. If you have all three roots distinct, this would have been your expression. Correct? And if you have one real and two imaginary, your expression would have looked something like f of x is equal to a times x minus alpha into some bx square plus cx plus d quadratic. This I could not factorize because this would not have real roots. Are we done with cubic? Yes. All right. So certain identities which will help you, make your calculations or observe things converted into forms that you can easily deal with. A square minus b square. A minus b into a plus b. This is your bread and butter. Which was the graph of one imaginary? It was this one. This, sorry, one imaginary root, you said. You can't have one imaginary root, right? Yeah, you will have two imaginary roots, which was this green graph. So one real, two imaginary. Yeah. All right, great. Uh, D in cubic. You can't have D in cubic. That is a one-off. That is only for quadratic. It's not a thing which can occur out of thin air. We defined the D because you can convert a quadratic into perfect square. And once you do that, you will find an expression for the roots which has this D getting manifested. So for cubics, there is no D. There is no formula for the roots. They will never mention the D word. The D word is something that you have to pick on. That yes, I will have to use the discriminant here. Yes, they are talking about the discriminant. So we are going to spend a lot of time on that part. All right. So let's first quickly wrap up the identities. A plus b whole square. A square plus 2ab plus b square. A minus b whole square. A square minus 2ab plus b square. A cube minus b cube. A minus b into a square plus b square plus ab. A cube plus b cube. A plus b, a square plus b square minus ab. A plus b whole cube. A cube plus b cube plus 3ab into a plus b. A minus b whole cube. A cube minus b cube plus 3ab into a minus b. So I will replace all. So yeah, this will be minus sign. Yeah. And a plus b plus c whole square. A square plus b square plus c square plus 2 times ab plus bc plus ca. So far, is everyone with me? Do you see that if they ask you for difference of the roots of a quadratic, a cube minus b cube, you will need the difference and this term a square plus b square plus ab, which you can convert into a plus b whole square minus ab. Correct? This is what sum of the roots. This is what product of the roots. Similarly, if you look at this, what are these? Some product of the roots. If they ask you for a plus b whole cube, or generally what they ask for is this a cube plus b cube or a square plus b square. If they ask you for a square plus b square, what will you do? This will be simply a plus b whole square minus 2ab. What is a plus b? This is sum of the roots minus ab is product of the root. So s square minus 2p. If they ask you for a to the power 6 plus b to the power 6, so you will first factorize it using a cube plus b cube and then deal with the remaining things. Your end goal would be to convert everything into a plus b and ab, because those are the two values that you know. All right, so these identities would be used heavily in certain situations where you will have to reduce the power. For example, if a to the power 6 plus b to the power 6 is given, I can write this as what? A square plus b square into a to the power 4 plus b to the power 4 minus a square b square. Can I write it like this? Yes. Now this you can write as a square plus b square whole square minus 3a square b square. This entire thing. And now a square plus b square, it's s square minus 2p, and a square b square also which is p square. So you can find this expression. So there are two more, there's one more fundamental concept which is called as defining a new function. So generally, if they give you something like x square plus 2x plus 3 is equal to x, find the real, what are the solutions to this? You would cancel this out and then find the roots for this quadratic. What you have actually done is you have defined a new function h of x, which is g of x minus f of x, and you have found the roots for h of x, because when h of x is 0, you will have g of x minus f of x equal to 0, or g of x is equal to f of x. This part is not that important to understand. This is the reality, this is what is happening, but you don't really need to do this. I think you are pretty confident that if they are giving me some expression of x is equal to some expression of x, I will take everything to one side and then treat the new equation as my polynomial, which is exactly what this h of x is all about. Now, your h of x can also be used for finding range in a very specific scenario: ax square plus bx plus c divided by dx square plus ex plus f. What they have asked you is what is the minimum or maximum value of this expression. Let's say that the value of this expression for any x is, let's say, capital H. Let us assume that the value is capital H. Now, can I cross multiply? Ax square plus bx plus c is equal to h dx square plus hex plus hf. And can I then take everything to one side and make a new quadratic x square into a minus ht plus x into b minus he plus c minus hf equal to 0. This is your new quadratic. What can you tell me about the roots of this new quadratic? Should they be real or should they be imaginary? Should they exist? For this entire thing to be equal to 0, what did you start with? By putting some real value of x as an input, right? The definition of h is dependent upon what? A real value of x. Which means even if I manipulate the expression and write it like this, the value of x is going to be what? A real number. So you find the discriminant for this, which is going to be in terms of h, right? And then you can find the range of that. Discriminant greater than equal to 0 is the constraint you will put. You will find the d in terms of h, b minus he whole square minus 4a minus ht into c minus hf, and that is greater than equal to 0. It will give you some constraint on d, either for maxima or minima. So they will set the values of a, b, c, d, e, f in such a way. All right. Finally, one more thing, which is the most predominant use of this trick, is breaking of patterns. So sometimes you get questions like, highly unlikely for CAT, but can be asked. A 4-degree polynomial is such that f of one is equal to you know uh, 2, f of 2 is equal to 5, f of 3 is equal to 10, and f of 4 is equal to 17. All right. First thing in questions like this is identifying the pattern. So what is the pattern? The pattern is x square plus 1. So each of these values is following what? 1 square plus 1, 2 square plus 1, 3 square plus 1, 4 square plus 1. Right? Which means if I define a function where f of x minus x square plus 1 is equal to g of x, can you tell me what are going to be the roots of g of x? The roots of g of x are going to be 1, 2, 3, and 4. Because at x equal to 1, what is the value of f of x? 1 square plus 1, which is 2. So this will cancel out. You will get g of 1 is equal to 0. What is g of 2? G of 2 will be f of 2 minus 2 square plus 1, that is 5, which is f of 2 is what? 5. So 5 minus 5 equal to 0. So similarly, you will get these four as the root, which means f of x minus x square plus 1 is equal to g of x, which I can write as a times x minus 1 into x minus 2 into x minus 3 into x minus 4. Because once I have all the four roots, I can write g of x is this. And they will probably tell you that the leading coefficient of x to the power 4 in f of x is 1, which would mean that a is 1. So now have you managed to find f of x? Now you take this minus x square plus 1 on the other side, you will get this as the expression for your f of x. Clear? And then if they ask you, and the most common question that they ask in these sort of situation is, what is f of 5? And most people will go and put f square plus 126 as an answer. No, that is not going to be the answer. The answer is going to be this. You put 5 here, you will get 4 into 3 into 2 into 1 plus 26. This will be your answer. The approach is very clear. You find the pattern, you write the pattern, then you define a new function h of x, which is f of x minus the pattern, and then you know that the roots of this f of x minus the pattern is, whatever the data points they have given. So you then write your h of x and then bring this pattern back to this side and find your f of x. And then for whatever value of input they have given you, you calculate that. F of 5 they have told you, then you calculate f of 5.